Just days ago, a nameless comet suddenly erupted in brightness near the Sun. Then the Sun itself unleashed its strongest flare in months, blasting a coronal mass ejection straight toward it. This is Comet SWAN, discovered just weeks ago and now racing on a collision course near Earth. Astronomers are stunned. Is this the start of a rare cosmic crossfire, with our planet watching from dangerously close range? With Comet SWAN set for a near pass in October and the Sun turning violent, the next few weeks could reveal a chain reaction few thought possible. The countdown begins now. So what happens when a comet and the Sun's fury align? On September 26th, telescopes across the southern hemisphere picked up a rapid surge in Comet SWAN's brightness. Observers logging data through the Comet Observation Database watched the comet jump to magnitude 5.7, suddenly visible to the naked eye from remote mountain sites in Chile and Australia. Within hours, reports flooded in. SWAN's tail stretched more than 2 degrees across the sky, its coma swelling and shimmering in real time. Astronomers scrambled to update forecasts as the comet's light curve broke away from every prediction, refusing to fade after perihelion. Then, less than 48 hours later, the Sun erupted. At 0843 Coordinated Universal Time on September 28th, an M6.4 class solar flare burst from active region AR4 232, launching a coronal mass ejection, a CME, across the solar disk. NOAA's space weather monitors registered a spike in X-ray flux and a moderate radio blackout. Solar physicists traced the CME's trajectory. Its expanding shell pointed toward the region of space where SWAN was arcing along its post-perihelion path. Dr. Helena Zirin at NASA's Goddard Space Flight Center flagged the event as the strongest solar outburst in months, noting that the ejection's vector lined up with the comet's orbital corridor. As the CME raced outward at nearly 1,000 kilometers per second, astronomers and amateur skywatchers alike waited to see if the solar storm would cross paths with the comet. The timing was uncanny. A comet in outburst, a solar flare, and a blast of plasma all converging in less than 2 days. For the first time this year, the Sun and a comet seemed locked in a high-speed encounter, with Earth just weeks from the action. Comet C 2025 R2, known as SWAN, first appeared in sky surveys on September 11, 2025. Its discovery came not from a ground-based telescope, but through the SWAN instrument aboard the SOHO spacecraft, a camera designed to map hydrogen in the solar system. SWAN's signature stood out in ultraviolet images as a spreading cloud of hydrogen, a telltale sign of a comet releasing water vapor as it neared the Sun. Amateur astronomers quickly confirmed the find, and within days the comet's path and brightness were being tracked around the world. SWAN had just passed its closest point to the Sun, or perihelion, on September 12th. At that moment, the comet was about half an astronomical unit from the Sun, roughly halfway between Earth and our star. This is the zone where solar heat begins to unlock the frozen gases buried inside a comet's nucleus. As sunlight reaches deeper layers, pockets of carbon monoxide and carbon dioxide erupt, blasting out dust and forming a luminous coma and tail. The scale of SWAN's tail is striking even by comet standards. In late September, its tail stretched 2.5 degrees across the sky, 5 times the width of a full moon. This immense fan of dust and ionized gas is shaped by both solar radiation and the solar wind, making SWAN especially sensitive to disturbances from the Sun. The comet's greenish coma comes from molecules like diatomic carbon and cyanogen, fluorescing under ultraviolet light. With each outgassing event, SWAN's tail grows longer and more dynamic, creating a moving target for solar storms and space weather. The SWAN instrument, acting as a cosmic detective, continues to document these changes, capturing the comet's evolution as it races toward Earth. On September 23rd, the astronomers' telegram lit up with alerts. 2 separate nova explosions had erupted: V745 SCO in Sagittarius and BY Circini in Centaurus. These stellar blasts, visible only to telescopes tuned to the right part of the sky, sent ripples through the global network of skywatchers. Just days later, as the world's attention lingered on these distant outbursts, Comet SWAN itself began to transform. Citizen astronomers, armed with nothing more than backyard telescopes and digital cameras, recorded a cascade of visible changes between September 27th and 30. Reports poured in from the Atacama Plateau, the Australian outback, and the South African Karoo. Observers described the comet's coma swelling, its tail fanning out and twisting as if caught in an invisible wind. Photographic stacks posted to astronomy forums showed the tail stretching and even wiggling across the star field, with some images capturing a faint ghost-like detachment, possibly a sign of the solar wind's first touch. The timing of these changes drew special attention. Within a single week, the cosmos had delivered a trio of rare events: twin novae flaring in the southern sky, a comet's light curve breaking all expectations, and a series of morphological shifts unfolding night by night. Amateur astronomers, sharing their findings in real time through COBS and social media, became the first witnesses to this chain reaction. Their logs and images, some later featured in Astronomy Picture of the Day, documented not only the comet's evolving structure, but also the sense of anticipation building among those who track the sky's every move. Comet Lovejoy's encounter with the Sun in December 2011 stands as a vivid reminder of what can happen when a solar storm meets a comet head-on. As Lovejoy swept past the Sun, a coronal mass ejection struck its plasma tail, slicing it off in a matter of hours. Spacecraft images captured the sudden disconnection, a dramatic, ghostly snap that left astronomers in awe. This wasn't just a fluke. Similar tail-severing events have been recorded with Comet Encke and others, each time exposing how sensitive a comet's plasma environment is to solar outbursts. Now attention turns to SWAN's own light curve. Instead of fading after its outburst, SWAN has held steady, its brightness refusing to follow the usual script. Photometry from the Comet Observation Database shows a flat line where a slow decline was expected. Some nights, the comet even brightens again, as if responding to unseen forces. These quirks have kept modelers guessing, with predictions for October's sky shifting almost daily. All eyes are locked on October 21st. On that date, SWAN will pass just 0.25 astronomical units from Earth, about 37 million kilometers, while in a separate region of the sky, the interstellar comet 3I/Atlas reaches superior conjunction, hidden behind the Sun from our view. It's not a perfect alignment, but the timing is rare. 2 major comets, one from the Oort cloud and one from beyond the solar system, both positioned for maximum solar exposure. The geometry puts SWAN in the crosshairs of any new solar eruptions, with Earth perfectly placed to witness the aftermath. For astronomers, this is a cosmic countdown, with every new data point raising the stakes for what might unfold as October's window approaches. For scientists tracking Comet SWAN, the explanation for its sudden outburst is grounded in well-understood physics. As the comet rounded the Sun after perihelion, sunlight penetrated its icy surface, triggering the rapid sublimation of hidden pockets of carbon monoxide and water ice. This process, called volatile outgassing, is a hallmark of comet activity and often leads to dramatic increases in brightness as fresh material explodes outward. Dr. Carl Battams, a leading comet expert with the SOHO/SWAN project, points out that these outbursts are natural and expected, especially for Oort cloud comets exposed to intense solar heat for the first time. When a coronal mass ejection sweeps past a comet, the most noticeable effect is a disruption or even disconnection of the plasma tail, spectacular to watch, but posing no threat to Earth. There is no evidence that comets can trigger solar storms or that these events are linked beyond their timing. October 21st marks the start of a high-alert watch window for astronomers worldwide. For 9 days, from the comet's closest approach through October 29th, teams will be tracking every flicker in SWAN's brightness and any sudden changes in its tail. The SOHO spacecraft's SWAN camera keeps up its daily hydrogen mapping, while Stereo's heliospheric imager scans for any signs of a tail disconnection or fresh outburst. Although no special mission campaigns have been announced, the routine cadence of these solar observatories means new data will arrive almost every day, sometimes within hours. Amateur networks across both hemispheres are preparing for rapid response imaging, hoping to catch SWAN at its brightest, possibly even visible to the naked eye under dark skies. The anticipation is palpable, with each new image and data point holding the potential for discovery. On September 26, 2025, Comet SWAN surged to magnitude 5.7, its brightest yet, just 2 days before the Sun released its strongest M6.4 solar flare in months, launching a CME toward the comet's path. Official logs from NASA's SOHO/SWAN instrument confirm the sequence, marking a rare alignment as SWAN approached its closest point to Earth on October 21st at 0.25 astronomical units. While some headlines link these cosmic events, current evidence shows no direct cause between solar eruptions and comet outbursts. Science points instead to natural volatile release. Still, the timing of stellar novae, SWAN's persistent brightness, and the approaching interstellar object 3/Atlas raise open questions. No known risk to Earth exists, but these converging events offer an unprecedented opportunity for observation. As the data continues to come in, the story of SWAN reminds us that even in a well-mapped solar system, cosmic surprises can unfold in real time, challenging what we know and revealing the dynamic forces at work above us.